Good morning, students. So in the last class we discussed about discovery of electron and how to find out E by M. Sorry, what is that? J. Thomson find out the E by M ratio. So that tells about what mass of the electron. Okay, E by M ratio, and the charge of electron is what is the discovery of electron is done by Faraday, and E by M ratio is done by J. Thomson. Okay, so by using those two values, so we can find out easily the mass of the electron. Okay, how? So listen. E value, we know that 1.6 into 10 to the power of minus 19 coulomb. Okay, so E by M ratio, how much we got? Sorry, how much we got in the SRS class? So 1.75882 into 10 to the power of 11 coulomb per kg. Okay, so we want mass. This is electron and it is charge. This is charged by mass. We want mass. So we have to cancel these two. So just write mass is equal to charge divided by E by M ratio. Then we will get mass. So this is 1.6 into 10 to the power of minus 19 coulomb divided by 1.75882 0 into 10 to the power of 11 coulomb per kg. Listen, this coulomb gets cancelled. Kg is in the denominator. If it goes to numerator means it becomes kg. Okay. So another one, if you divide this, you will get the value 9.1094 actually into 10 to the power of minus 31. Okay, so you will get the value 0.91094 into 10 to the power of minus 30. Listen, minus 19 is there. This 10 to the power of 10 is in the denominator. If it goes to numerator, here it is 10 raised to minus 19. So if this goes to numerator, it becomes raised to minus 11. Minus 19 minus 11 means minus 30. So listen, this is 1.6, this is 1.75. Of course, the value becomes 0.91094 into 10 to the power of minus 30 kg. We are just shifting the point. Then we will get 9.1094 into 10 to the power of minus 31 kg. Understood? So this is what mass of an electron. Understood? This is mass of an electron. Charge we discovered, this is mass. Sorry. So mass of a nucleus. Okay, electron doesn't have any mass. Remember that. Later I will say what is that mass, what is this value. Understood? So the mass value we got this much. So we consider this one as a mass of an atom. Understood? Okay. At that time, of course, it is not only mass of a single atom. It is mass of a proton actually. But later I will say what is the mass of atom and how can we compare this value with the atom nucleus and all. Understood? So this is how to calculate. This one is, remember, mass is 9.1094 into 10 raised to minus 31 kg. So later, students, what you have to remember, so we discovered electron and we discovered E by M ratio. Still we don't know neutrons and protons. So next one, another one scientist, okay, not another one, that Faraday only itself just rearranged the cathode ray experiment. You know cathode ray experiment? One cathode is there, another one anode is there. So like this. Here vacuum is there. Okay. Here cathode is there. Here anode is there. They are connected to the external battery. Correct? This is high voltage, this is vacuum pump, this is cathode, this is anode. And here gaseous atoms are there. This is the cathode ray experiment. When the electricity is passed, means high voltage is passed at low pressure, then the rays start moving from cathode to anode. Those are called as cathode rays and they are not affected by any electric field and magnetic field. I told you in the last class in the discovery of electron. Same experiment is just altered. Understand? Same experiment is altered. So what is that experiment? So listen, here instead of considering the canal rays, by arranging the conditions, we have to consider these anode rays. Anode rays. Anode is in which charge? Positive charge only. Cathode is negative charge. Correct? So anode rays means the rays which are positively charged. Understand? Of course, those are also cathode rays only. They are also emitted from this to this. But the thing is, they are positively charged. Means the positively charged rays which move towards cathode from anode. Anode is positive in charge, cathode is negative in charge. So those rays are called as canal rays. So in the yesterday's class, I often mentioned, so cathode rays is there, at the same time canal rays are there. But in the discovery of electron, we consider only cathode rays, we ignore canal rays. But in the discovery of proton, we need to know this canal rays. Canal rays means the positively charged rays emitted from anode moving towards cathode. Cathode rays means a negatively charged rays moving towards anode from cathode. Just opposite. Okay, cathode to anode, cathode rays. Anode to anode rays are canal rays. Understood? So from this, of course, we can easily say, of course, they are moving from anode to cathode means they are positively charged. Experimental result I am telling. They are positively charged. Understand? And the rays deflection is depends on nature of gaseous atom. Means if gaseous atom is lighter, then the deflection is less. If the what is that? Gaseous atom is denser, means heavier, mass is more, then the deflection is more. Here it is opposite. Remember, in cathode rays, lighter the molecule, greater is the deflection. In the last class I told you. But here, if the lighter the molecule, least is the deflection. Why? Because, listen, here we are considering positive rays. Positive rays means, you know, nucleus is there. In the nucleus, protons, neutrons are there, and electrons are here. If smaller the mass means, the mass of the atom mainly depend on this proton and neutron means nucleus. Electrons are not having any mass. Are you getting? So, completely, whatever, if you write C6, 12, 12 is the atomic mass, you know that. So, this atomic mass of carbon is due to what? Only protons and neutrons. Electrons are not affected to the mass of the atom. Understood? So, if the nucleus is small, smaller atom means nucleus is small obviously. Then deflection is also small. If nucleus is big, then deflection is also big. Are you getting? Listen, for example, hydrogen I take. Hydrogen is 1s1 configuration. Only nucleus is this much. Only one electron, one proton is there. There is no neutron. So smaller. Next, if you take neon, it is 10 electrons. Similarly, 10 protons. Understood? So the nucleus is this much big because consists of 10 protons and neutrons. This is small, this is big. So of course if the size is more, deflection is less. Okay? If the size is less, Sorry, if the size is more, deflection is more. If the size is less, deflection is less. In case of what? Canal rays, because only the nucleus is positive in charge. So we are checking here the positive rays. Positive rays emitted from where? Not from electron, they are emitted from this nucleus. If they are positively charged, they should be emitted from this nucleus, not from here. Electrons are obviously they are negatively charged, not positively charged. Understood? So if the size is less, deviation is less. Size is more, deviation is more. But in case of electron, if size is less, deviation is more. But size is more, deviation is less. Means mass. Understood? Just vice versa there. So obviously you can easily remember, if you know the cathode ray experiment, exactly opposite of cathode ray experiment is the canal ray experiment. Okay, there cathode negatively charged rays are emitted, here positively charged rays are emitted. Okay, here they depends on the nature of gaseous atom, they also depends on nature of gaseous atom. So in the cathode, lighter the mass, lighter the molecule, greater is the deviation. Here lighter the molecule, least is the deviation or a deflection. Understood? Next, another one. So the magnetic field, the application of magnetic and electric field affects or acts exactly opposite to that of cathode rays. Means the magnetic field and the electric field are also affected, but that is exactly opposite to what cathode rays. Means, so listen, after this I say, if this is the cathode ray experiment, your goal is there, so this is deviated like this. In the last class I explained this is point A, point B and point C, right? So here, if we apply magnetic field to the cathode ray experiment, then it is deviated at or spotted at point or reflected at point C. Understood? This is for magnetic field, this is for electric field. This is for what? Cathode ray experiment. In case of canal ray experiment, means anode rays experiment, reverse. So what happens? The application of magnetic and electric field acts exactly opposite to that of cathode rays. Means cathode rays, on applying magnetic field, if they deviated downward. So if it is a canal ray, of course it is deviated upward. Okay. If we apply electric field, the cathode rays are deviated upward. If it is canal, means it is deviated downward. Of course, it is also affected by the magnetic field and electric field, but it is exactly opposite. Okay, so you know at that time so many atoms are there. You know already that periodic table is already discovered. So in the 1919. In the 1919, at that time, modern periodic table, they have an idea towards the modern periodic table of 118 elements. So among them, he tried what is a canal ray experiment for all the atoms. In that, only hydrogen atom liberate a lightest, smallest positive charged rays. You know, as I told you, if lighter the mass, lighter is the deflection. Greater the mass, greater is the deflection. So we have to take least, which one is very smallest, that is the fundamental particle or a fundamental thing. Okay, you know, in our body, cell is the fundamental unit because it cannot be divisible, you know that. Understood? Which one is very small, that is called as fundamental, means key, very first. So in this all the atoms, so many protons are there, you know that. Only in hydrogen, only one proton is there, one electron is there, there is no neutron. We have to find out proton here, not neutron. Are you getting? We have to find out only proton. So this hydrogen consists of only proton and only electron. So that's why, listen here. He conducted a canal ray experiment for this proton, and this emit a least lighter positively charged molecule that is called as proton. This is how the proton is discovered. Understood? Only one ray of proton is formed. Okay? So that's why this is called as proton. How it is discovered? By canal ray experiment. Just by resetting the cathode ray experiment setup. Understood? So this is canal ray experiment. Understood? Next, another one is discovery of. So we got electron and we got proton, and another one we need to know is what? Neutron. Okay? So this neutron is not calculated or discovered or identified by any chemical experiment. This type of physical experiments. Okay? So they're done by bombarding alpha particle with beryllium atom. Okay, so it is the discovery of neutron. Okay, this is by James Chadwick. Okay, the proton is discovered by Millikan. Experiment is Faraday's, of course, but the protons are discovered by Millikan. Electron is by Faraday, and this neutron is by Chadwick. Remember that. Scientists who discovered fundamental particles. Okay, so bombarding alpha particle with beryllium atom. Okay, so students, we came to know, of course, electron is there, protons is there. So along with that, in the some experiments, they cannot satisfy with the only protons and electrons. If only proton is there, then, so listen here, if I say carbon 6 and 12 is there. Okay, I am taking this one as the example. So proton has mass 1, you know that. Approximately, the mass of proton is 1. Okay, here 6 protons are there. If the protons only present, then the mass must be also equal to 6. But here mass is equal to how much? 12. Okay. For hydrogen, of course, no matter, proton is 1, neutron is 1, neutron is 0, electron is 1, nothing is affected. If you take helium, 2, 4, if proton only present, understood? At that time, as I told you, already the periodic table is generated, modified, or prepared. Okay? So if only protons are there, then proton is 2, then atomic mass must be equal to 2. But here atomic mass equal to 4. What is the reason for increase in the atomic mass is the question. Understood? What is the key point to work on this neutron means this one. Even only electron is there, only proton is there, and they are electrically balanced. Minus charge and plus charge is balanced. So even though the mass of the proton is greater, mass of the atom is greater than number of protons. What is the reason for that is their question. So that's why they start doing an experiment to discovery of neutron. What they did? Bombarding alpha particle with beryllium atom. So beryllium means it is 4, this one is 8. Not 8, sorry, 6, I think so. Okay. So listen. Beryllium is there. Wait a second. It is 9. Okay. Beryllium is B49. So students, when it is bombarded with alpha particle nothing but, so alpha is equal to He24. Why? Because alpha particle consists of 2 electron, 2 proton, 2 neutron. If it is equal, if it is like that, then it is called as alpha particle. This alpha is equal to the configuration of this He24. In the place of alpha, you may take He24 also. When they bombarded this, when they are this alpha particle strikes this beryllium atom. So then what happens? Listen, here atomic number 6 will come, 4 plus 2. Then 9 plus 4, 13 is there. Instead of 13, it forms 12. C, 6, 12. Carbon will form. By bombarding beryllium with this alpha particle. The remaining is what? Here it is satisfied, here extra 1 is there. 9 plus 4, 13. Here 12 is there. Another one is this neutron. Okay, so by bombarding the alpha particle with the beryllium atom, they got this stable compound carbon along with the emission of the neutron. From this experiment, he concluded that so in the atomic mass, not only protons are there, not only electrons are there, even though neutrons are there, and the charge of neutron is 0, and the mass of neutron is 1. We calculated that. Understood? So this is all about the discovery of protons, neutrons and electrons. For neutron only one experiment is there, only this much. There is no any experimental setup and all. Okay, experimental result is what? When the alpha particle is bombarded, strikes the beryllium molecule, it forms stable carbon compound along with the elimination of the neutron. Understood? Okay, this is what discovery of neutron. So now we have proton, neutron and electron. The thing next comes in our mind is what? So how they are arranged. So you know hydrogen atom, oxygen is there, nitrogen is there, and the metals are there. For copper, iron, they are exist in earth. Okay, in earth crust they are available, and these gases are exist on earth. In our body also so many atoms are there and stable. Okay, they exist means they're stable. What is the reason for the stability of those atoms? If the atom consists of the protons, neutrons, and electrons, how they are present inside the atom? That is what structure of atom. How the atom is designed with these subatomic particles. So to explain the stability of the atom, so many atomic models are proposed. Okay, so in that the most important is 4 models. So one is J.J. Thomson model. Okay, another one is Rutherford model. Next, Bohr's atomic model. Last one is quantum atomic model. Okay, 4 types of models are there. First one is J.J. Thomson's atomic model. Second one is Rutherford atomic model. Okay, third one is Bohr's atomic model, and the last one is quantum atomic model. This is what we are using in a present days. Okay, so listen, I'll explain this J.J. Thomson model first. Okay, so what he did is in the J.J. Thomson. So listen, in the 1898, he proposed this atom. Okay, listen. So in the 1898, the neutrons are not yet discovered. Only protons and electrons are discovered when he suggested the atomic model. 1898. Understood? So what he considered, so atomic model is in such a way the positive charged species are uniformly what is that? Arranged throughout the atom, are uniformly distributed throughout the atom. For example, consider this is the boundary of an atom. This is the boundary of an atom means the positively charged species, because we don't know negatively charged neutrons are present at that time. Understood? So here what happens? This one. The positively charged species are uniformly distributed throughout the atom. Okay? So along with that, electrons is also there because electrons are already discovered. So to maintain electrical neutrality and it find out the negatively charged species are also distributed in them in such a manner, are just trapped between them. Only positively charged species are distributed throughout the atom. Okay, negatively charged species are distributed within them, like this. He arranged like this. Okay, just an assumption it is. Understood? So this model is look like a watermelon. Means that red color part in the watermelon, the red part is considered as the positively charged species because throughout the fruit it is there, and the seeds which are interrupted in that, seeds which are present in the red color part, those are considered as negatively charged species. That's why this is also called as watermelon model. Okay, so it is not only called as watermelon, it is also called as pudding, plum pudding model. Okay, next rising pudding, rising pudding model. So most this is also called as watermelon model, J.J. Thomson, plum pudding and resin pudding. Means it looks like a watermelon fruit. Understand? Why? Because they compared the positively charged species with the red part of the fruit and the distributed negatively charged electrons as a seeds inside that. Understood? So this is what J.J. Thomson model. Of course, at that time, in the era 1906, he awarded Nobel Prize. In the year 1906, of course, he awarded Nobel Prize for his atomic model. But later, when the neutron is discovered, okay, at that time, of course, he didn't mention any neutron inside the atomic model. Okay, and later some reactions they did. So due to that reactions, they came to know. Of course, this fails to explain some of the experiment which we can expected experiment results we cannot get by using this type of model. Okay, that's why later this is discarded. Initially, it is considered because no one is not yet to no one is discovered the atomic model. He only discovered, that's why he awarded Nobel Prize in the year 1906. But later, after so many experiments, they came to know this atomic model is wrong. Understood? And it is discarded. Of course, this is the first atomic model which is proposed by J.J. Thomson. Okay, so the next model is what? This Rutherford model. So when this model is discarded, when it is discarded, when the Rutherford gave a brief explanation about the model, atomic model of the other atom, including proton, neutron, and electron. Understood? Okay. Listen, what is that? Rutherford experiment tells. So students, this Rutherford to suggest a structure of atom, he conducted an experiment called as alpha scattering. Rutherford alpha scattering experiment. Okay, so what is that experiment? So listen, here he considered a source of alpha particle. This one is a source of alpha particle. Okay, so these alpha particles is passed through this lead plate. Okay, this is the lead plate. Passed through this lead plate is made hole in this. Okay, so this lead plate falls on the gold foil. This one is what? Gold foil. Okay, so around this gold foil, when this alpha is placed on, falls on this gold foil, they scatter. Later, to know that scattering, he placed a fluorescent material around the gold. Understood? So this is the experimental setup. This one is zinc sulfide screen. You take or plate anything. Zinc sulfide made up of zinc sulfide screen. Understood? So this is the experimental setup. So what happens here is a source of this is what alpha scattering. Scattering means what? This type of spread. Scattered light, convergent light. You know, convergent means the light are focused at one point. That is convergent. Divergent, you know that the scattering nothing but divergent. From one point they are diverged like this. You know, headlight. Automobiles are there. Those headlights are the example for scattering of light. So headlight are still but light is just cover madutata. That much of space. So that is what scattering of light means. The light splits, it diverges. So listen, how the experiment takes place, listening. The source of alpha particle emit the alpha rays. Alpha means what? He24 or alpha24 type of. When they emit the alpha radiations, they pass through the hole because we want a sharp alpha particles. We need to know which are divergent, which are going to be deflected, which is undeflected, like that. Understood? So remember here, this is what a hole is made in the lead plate. The alpha particle is passed through that hole and falls on this gold foil. Okay, so when they falls on this gold foil, they diverge. Some are diverge in this manner. Okay, so listen here, what I am doing. Some are again reflected back, some are deviated, some are in a straight. Listen here, some are is directly falls on the screen, some are reflected from the screen at a 180 degree, again completely they reverse back, and some are at a different angle they are deflected. Understood? Some are even. So I say listen, how it happens? Listen. These are the atoms you see. Electrons or protons are present in the gold foil you see. Okay. So students, this is the gold foil. Of course, gold consists of protons, neutrons, and electrons. Here, this is the nucleus. Protons, neutrons are there. This is the electrons. So I'll just rearrange this like this. This is the proton, nucleus of proton and neutron of gold. Okay, this is electron revolving around that. So this is the atomic model, just as that. So when here this is the alpha rays are scattering, this is the gold plate. In that nucleus is the electrons are revolving around the gold foil. Okay, so why some are deflected? Here I write some are undeflected. The result I am telling. Some alpha rays are undeflected. Next, some are deflected at small angle. Okay, and another one is some are reflected exactly or deflected exactly 180 degree. Some are undeflected, some are deflected at a small angle, and some are deflected exactly 180 degree. Means they bounce back. Okay, listen. However, what is the reason for that? Some are undeflected. Here, how we can confirm? So listen, students. If some rays are falling on this gold foil, okay, so the deflected light or either their emitted amount that is confirmed by the a sharp spot light on this zinc sulfide screen. If the any rays, alpha rays, if they touches this zinc sulfide, they create a spot of light on that screen. Okay, so listen, why they are undeflected? Here, nucleus is here, electrons are here. Electrons are continuously revolving around. Then what happens? Assume if the alpha rays are transferring from these electrons means, of course, they are not affected by anything. Empty space is there, so they travel undeflected. Listen, in this place, how many alpha rays are going to pass? They will, they pass as undeflected. They pass through that gold foil as undeflected. Okay, so listen, when they approaches near this nucleus, so listen here, it approaches nucleus, is slightly deviated. Are you getting? When they approaches this, is slightly deviated like this. Deviation takes place. Next year also in rain. If they pass here, then they are pass through like this. If they approach us exactly, then they deviate. So students, when they are exactly at the center of the nucleus, when they cannot pass through the nucleus, so listen, I will take these rays here, a strong rays. So this is the nucleus. So the rays cannot pass through, it means exactly bounce back. Okay, here in the same, of course, only one gold foil is there. The alpha rays are keep on falls on that gold foil and they are deflected. In that deflection, types is there. Some are undeflected, some are deflected at a small angle, some are bounce back at a 180 degree angle. What is the reason for that? This is the reason. So atom is there. That atom consists of what is it? A small portion. What is that? The volume of the entire atom and the volume of the nucleus is comparatively negligible. Volume of the atom is this much, volume of the nucleus only this much. Means the nucleus is here, the atom, the size of the atom is this much. Are you getting? If the alpha rays is falls exactly on the nucleus, they bounce back. If the alpha rays they are passing near the nucleus, they deflected in a small angle. Okay, the alpha rays which falls exactly on the nucleus, they falls back. The alpha rays which is moving nearer the nucleus, they deflected in a small angle. The alpha rays which are moved far away from the nucleus, they remain undeflected. So that means the difference in or variation in deflection due to what? The presence of this nucleus. Okay. So from this experiment, we came to know. So in an atom, okay, a concentrated mass is there. That mass is called as nucleus. We consider a small concentrated mass is there. That mass is called as what? Nucleus. Thus, nucleus consists of protons and neutrons. Understood? So, the volume of the nucleus is negligible compared to volume of the atom. Volume of the nucleus is negligible compared to volume of the atom. Okay, so then he said, of course, in around the nucleus there are so much empty spaces there that is covered by electrons. Around the nucleus, so much empty space is there that is covered by what? Electrons. Those electrons are moving in a circular path around the nucleus. That path is called as orbit. Okay, these are the conclusions he made from this alpha ray scattering. So from this he exactly says, so atom, it has a concentric circle, not concentric circle. Okay. So he has a concentric mass that is called as nucleus. Okay, so the electrons are revolving around the nucleus. That path is called as orbit. So this is the model suggested by Rutherford by the alpha scattering experiment. Understood? These are the observations. These are the experimental results. This is the conclusion. Understood? These are the observations. Some are undeflected, some are deflected at a small angle, some are reverse back. This is what? This is observation. This is the not conclusion, observation he did. What happens? Reason. Because undeflected rays are passing away from the nucleus, small deflected rays are passing nearer the nucleus, and the one which are bounced back, they are exactly falls on the nucleus. Okay, this is the conclusion, and that is the final result. Because the nucleus is atom is like this, that's why we are getting this type of result. Understood? So this is the second atomic model of atom. Okay. So in today's class we studied discovery of proton, okay, discovery of neutron, and this J.J. Thomson model, Rutherford model. In all these, only the experimental results, postulates, and conclusions are important, not this experiment at all. Understood? They won't ask procedure. They'll just ask what is the result, what is the conclusion, what is the final result. Observation, conclusion, final result. Understood? Okay. So in the tomorrow's class, we will discuss with the remaining atomic models. Thank you.